This example comes out of section 6.3, proving identity. We're asked to prove this identity, cotangent x minus cosecant x equals cos 2x minus cos x divided by sine 2x plus sine x. Set up my left side, right side table, save myself a little bit of writing, and I end up with something that looks like this. Let's use some identities right away to make us speak a common language here, cosine and sine. So cotangent is cos divided by sine, and cosecant is 1 divided by sine. That's pretty handy just because they already have a common denominator, so I can write them as one expression, cos x minus 1 over sine x. Definitely doesn't yet look like the right side, so the right side I need to think about this for a second. The numerator, I've got cos 2x minus cos x. Once again, you have choices of which of the three forms of the cos 2x identity you choose, but the smartest one to choose here is that equals 2 cos squared x minus 1. The reason why is because it's going to turn into a factoring question. On the bottom, again, I don't have choice. When I have sine 2x, it automatically becomes 2 sine x cos x plus sine x. The top there, the numerator, is a factoring problem. Maybe to emphasize the type of factoring problem it is, I'll write it in order that I usually write those. The bottom, I could factor right away as sine x out of it, and I've got 2 cos x plus 1. Now that numerator, if you were asked to factor 2n squared minus n minus 1, hopefully you would think what two numbers multiply together to equal negative 2, and then they add together to equal negative 1, and they are negative 2 and positive 1. And so 2n squared minus 2n plus 1n minus 1, factor them 2 by 2, and you end up with 2n times n minus 1 plus 1 times n minus 1, means that this is n minus 1 times 2n plus 1. So there's a Math 10 factoring review for you. But what that means for this question is that this is 2 cos x plus 1 times cos x minus 1. Once I factor it, on the bottom I have sine x times 2 cos x plus 1. The beauty of factoring things is once factored, common factors can go away if they're on the top and the bottom, and I'm left with cos x minus 1 divided by sine x. Beautiful place to be, because the left side equals the right side, and we've proved